Hello, Granada and VEAI. Thank you for accepting this recorded presentation. Our designated speaker fell ill with the flu yesterday, so there was no other person to travel to Granada in such a hurry, and we had no other option but to record it to avoid any networking problems. I am Lionel Morgado, and Hugo Paredes will be available for your answers and clarifications after this talk. It is about integrating virtual worlds with learning management systems, and we call it the MULTIS approach. The context is large-scale e-learning. MULTIS Labs provides the Formata LMS. This is a learning management system that is corporate-centric. Its user base is around banks, insurance companies, etc. So any given course can have thousands of users and dozens of trainers with significant management requirements. We created several 3D spaces using Open Simulator, and these customers of Formata were able to use it. The main concern is that in such a context, you really need to be able to manage what takes place from a web interface and not from the cumbersome and almost clutchy alternatives that you have here. Typically, when you talk about integration of visual world systems, you think of systems like Sloodle. There was also a Blackboard effort to integrate Second Life. There was a now defunct LMS called VEAI. But all of these approaches require trainers to play the seven instruments altogether. Roughly, they are not thinking about the organizational context where managers need to purvey the same level of experience for all trainers and all trainees. From our perspective, full integration is about making the 3D environment a managed part of the learning experience. So management takes place on the same kind of platform and with the same kind of content features. So in our view, the learning management system is the source of the learning content, is the store for the learning content, and commands what happens. We first established the requirements around over 4 years of joint work between universities, research laboratories, and the corporate Altis Labs company. This was published last year as requirements at the iLearn conference in Santa Barbara, and we do welcome you to join us again next year in Coimbra for the iLearn 2017 conference. Submissions are open until February. So sorry for that plug, but moving on. We did identify 4 problem vectors, and this is explained in the paper. So the first problem vector is how to store the content as a visual world in the context of the learning management system information system. Our approach for this is to use LMS-controlled bots as a data store. The learning management system actually will be able to control several bots, several automated clients, and it's invented the data store for the learning management system. Then a second problem is about how to place content into the virtual world. Our solution for this problem vector is to use also learning management system controlled bots and have them act upon the virtual world. If you need a particular space or tool available for an e-learning session, what the LMS does is prior to that session taking place, go into the virtual world and act upon it, creating all the necessary environments. We have detailed this approach in the Journal of Universal Computer Science on a paper earlier this year, which we invite you to read. This presentation will be available on both SlideShare and YouTube later. Our third problem vector is about receiving in the LMS the virtual world events and data. Our approach for this is a combination of visual world scripts and web services. So we create specific web services in the LMS to accept virtual world event reports, and we created a single LSL script. This script basically provides event reporting and responds to any web service decisions and even deploys those decisions to other copies of the script in other objects and locations. We do detail this on a paper on entertainment computing, which came out 2 years ago. We also invite you to read it and check out our approach. The fourth problem vector is how to control visual world platforms of the learning management system. Our approach is to add the bots, the LMS-controlled bots, inject or and delete scripts, and provide parameters for specific scripts. So instead of having to customize every single space, the LMS can simply go to a given space and turn on abilities and features on the spot using this approach. To achieve this, we created an architecture where the virtual world is the minimal content. It can accept bots or run bots. It can accept virtual objects and run scripts. And the learning management system, which is formatted, will have the core LMS with its logic. And we added two extra modules. We added virtual world web services and we added bot logic. Conducting a first analysis, we determined that there was a performance bottleneck. Bots would have to deal with a lot of commands and worries, and so it would sometimes compromise performance. Our solution was to create the concept of bot spooling. This was presented on that earlier mentioned paper, and so the formatting LMS has a bot pool and a bot spooler, and so when something needs to be done, the bot spooler will select an available bot, and that available bot will go into the virtual world. Any other request can use an extra bot. This bot spool can be enlarged or shrunk according to specific needs, and so the bottleneck problem is quite alleviated. In that same paper, you can check the details. We strongly encourage people to check and contact us in any doubt. We would like and love for this to improve and be more widespread in use. In our current paper for VEAI, we do detail all these problem vectors and we also provide 3 cases of application to clarify how our solutions work. Here for this presentation, we are just detailing one, which is for requirement 2G6. That requirement is that 3D objects should have user profile-based permissions. That is, if I have a slideshow projector, for instance, I should be able to determine which users use it, not depending on whose avatar is clicking, but on what is the current profile of that user in that e-learning session. Is the user a teacher, a trainer, an invited speaker, or a student? What? Please notice that a user can be a student in a course and a trainer in a different course, but have the same avatar in the virtual world platform. So this does not depend on the avatar, but on the e-learning profile. For this, we use solution vector 3, virtual world scripts and web services. So the script in LSL language detects the interaction with the slideshow projector and reports the event to the LMS web services. Then the web services on the LMS matches the avatar ID with the user ID in the learning platform, decides on the outcome of the action, and accordingly, the LSL script will receive the response, and depending on it, it could enable the slideshow, it could ignore the usage attempt, or shoot some other behavior like providing an explanation or a warning. Our next steps are to expand the integration approach to serious games and other platforms. We do intend to make this approach a way for serious games in virtual worlds to become a seamless part of e-learning platform and management and so become more widespread in application. For that, we intend to study cases of training with immersive virtual environments to further clarify requirements and features needed. In particular, we are quite interested in identifying more adequate workflows and implement novel LMS support for those, because we do think that we should realize that virtual worlds should enable management, trainees, trainers, teachers to do different kinds of workflows and be able to support them. Finally, please remember that iLearn 2017 will be a great conference. Sorry for the plug, but we do think we are creating a great conference, and do come to Coimbra. Submissions are open until February the 1st. So we have Hugo Paredes on Skype for any doubts and questions you may have.